Do microphones need power to work? The answer is sometimes. It depends on the mic, and you can't just plug mics straight into the wall. That's not how that works. So what do you do to give the mics the power that they need to function? That's where phantom power comes into play. But in order for phantom power to make sense, we have to go through the mechanics of the microphone. Now, there are two main types of microphones, dynamic microphones and condenser microphones. We'll start with dynamic microphones since they're a little easier to understand, and condenser microphones can get complicated. This is an example of a dynamic microphone. It is really sturdy and rugged and tough and durable, and it's really good at isolating sounds in noisy environments and being able to withstand very loud environments, but because of that, it's not super sensitive. Let's break down the mechanics inside the microphone and how they work. So they contain a diaphragm. That is what moves when there is a change in sound pressure, aka the noise going through the mic. The diaphragm then moves the coil that it is attached to, which is inside a magnetic field of a permanent magnet in the mic. The coil then vibrates inside the magnetic field, causing an alternating current to flow in a circuit similar to the incoming sound waves, basically mimicking the frequencies going into the mic. So now that we know how dynamic microphones work, we can move on to condenser microphones. And these are the mics that actually need power to work. So this is an example of a condenser microphone. They are more sensitive, so they're not suitable for loud environments like the dynamic microphones are, but they're better at picking up quieter sounds and have a better representation of higher frequency noises. So let's talk about how they work. Condenser mics have a diaphragm that is made out of a thin metal plate that sits in front of another plate called a backplate. They form a capacitor. And condenser is actually the older term for capacitor, but condenser mics are more known than capacitor mics, I guess, as a term, but capacitor and condenser can be used interchangeably. So the capacitor/condenser can store small amounts of electrical energy. So when there is sound coming through the mic, the diaphragm moves and changes the distance between the two plates. This changes the electrical signal that passes through the circuit, mimicking the pattern of the incoming sound waves. So unlike our friends, the dynamic mics, the condenser mics are active, meaning they require external power to function. See? Not that hard to understand. Now this is where phantom power comes into play. Now, phantom power is usually supplied through an XLR, which is the mic cable, and there are other scenarios where it can be supplied through a power adapter, USB connection, or an internal battery, but those aren't as fun as XLR and phantom power, so we're not going to worry about that. Phantom power is really fun because it's typically provided to the microphone through an XLR from an audio interface, preamp, or soundboard/mixer, and it's all done with the press of a button, usually labeled Phantom P48 or plus 48V, something like that. With the XLR being 3 pins, it's able to carry information to and from the mic as well as carry the electricity needed. So pin 1 is 0 volts, while pins 2 and 3 are 48 volts each. Hence the 48V plus 48P whatever it would be labeled. So phantom power is typically 48 volts. Now this is where things can get really complicated, but we're going to keep this simple. Phantom power is a low voltage power supply and it carries DC power. It can range anywhere between 9 volts to 52 volts, but the industry standard is 48 volts. Those are the stats, in case you were wondering. Now, the name Phantom is not because of Phantom of the Opera or anything crazy, it's because you essentially don't see it. It runs through the cable, there's no external power source that comes through it, or you don't plug it into a wall, it's essentially invisible. But phantom power should not be used for every mic. There are dynamic microphones, like we discussed before, that do not need phantom power. So it's very important that you read your manuals so I don't get blamed for anything that you do wrong. Because sometimes it can destroy and damage the mics that don't need it. Because imagine sending electricity to something that doesn't need it. It's not going to be a good outcome. So don't blame me. Make sure you read your manuals and see if it's needed. That's also a big problem where sometimes you feel like you've done everything and the mic just isn't working, it's not picking anything up. It's because you need to turn on phantom power. So make sure you check. It's always important to check. It's crazy to think that we've been hearing phantom power in action all the time in the music that we listen to, TV shows we watch, shows we go see, some finance bro podcast probably for some reason, and you didn't know how they worked, and now because of me you do. You're so welcome. It's crazy. But phantom power was a very interesting thing to learn as an audio engineer. It didn't make sense for me at first, so hopefully this makes sense for you. If not, rewatch the video 4 or 5 times and maybe it'll click. Try my best.